Welcome to the shell lesson for NLP of the NLP carpentry. So I'm going to start my shell lesson. I have a folder in my desktop folder with my ID. So I'm going there. Okay. So here I have, if I ls-l-h, then I can see that I have two stuffs here. So one is datashell.zip and sh.txt. So I downloaded these for the shell lesson purpose. So I'm going to unzip this datashell.zip. So if I now ls here, so I can see that there is a folder called datashell. Now I will remove the zip file, as I don't need this anymore. So if I do this again, then I can see that it has two files, one folder and one files. So at first I'm going to go to the molecules folder inside this datashell folder. So there is a molecules folder, and if I do ls here, I can see some .pdb extension files here. So if I run this single command, so I need to clear the window first, and I will run this wc command. This command basically gives us, so I'm using a wildcard here. So this wildcard is actually helping me out to go through every file that has .pdb extension, and there are three columns here. These are first column actually the line numbers, second column is the word number, and third column is the character number, I think. So this actually gives me the every calculations here. But if I need to see just the line numbers, then I go with this column. So now I can see just the line numbers here. So if I do a filter, I can use pipe here to filter those stuffs like this. So I will use sort -n. So I can see the outputs are sorted. Here it's not sorted, but in my second command it's sorted. So if I want to see the first two files, so I will give -n2, which means I just want to see the first two files. So here is methane.pdb and ethane.pdb. Is the sorted versions, first two lines actually. So now if I want to do this, if I want to see the output in a different separate file, then I can do this read first 2.txt. So I'm making a txt file that will read just the first two sorted outputs. So if I ls now, I can see in this folder, there in this directory, I get a txt file which I mentioned here. So in this if I run cat command here, I can see the outputs are similar like this. So we can create file like this. We can just run a command and make an output that will go to in a directory. And if I just run this command again, and if I do this so if I do this, then it will concat the current output to the bottom of the file, I think. So if I cat this again, you can see it's shown two times, because this file concatenated these two outputs. So now I will go to another directory called animal counts. It's in the data directory, so I will do cd dot uh, data. So basically what I'm doing is I'm going back to the data shell directory and then data and animal counts. Here is a directory called animal counts. So here is a animals.txt file. Now I will do some command operations here to see certain outputs, like cut command. Cut command is basically, so if I cat this animals.txt file, I can see that there is 3 columns basically, and which are separated by delimiter comma. So I need to find a single column with, so I will use -d, which will cut the delimiter and I will choose my column. -f is for the column, and then I will give the file name. So this is the first column because I give 1, so it's showing the first column. But if I give there like 2, then it will give me the second column. Now if I do the sort -n command, then it will sort the output beer, deer, but there are some repeated output, so I want to take just the unique one, so I will use unique keyword, so that will give me the unique outputs. Next, I want to go to another directory to show some other lesson. So for example, I want to go back to the data shell folder and then North Pacific Gyre, and there I will have a folder or directory which is a date basically. So I'm giving a tab and it's there. So here you can see some files. So these files are, if you notice that these files have some common expressions. So these are the numbers, then A, then there are some numbers, the B, but there are some numbers, then Z. So here are some A, B, so these are the constants. So if I can write an expression that can define all the files that starts with any and ends with a.txt or b.txt. So how will I do that? So for example, for my demonstration purpose, I will create this stats.txt file. I will not input anything here. So if I ls here, I can see the stats.txt is here. So now I will do something like I will, so for example, I want to write a script, shell script. So what will I do is nano so .sh file. So here I will write a script which will be like for data file in, so I'm gonna use another wildcard, which is I think this one, then do go data file, sorry, I need to give a $sign before because it's already declared up. So now I will give another tab and head -n 2. I want to see the first 2 lines. I want to take first 2 lines, then data file, from the data file, and pipe it to sort. So it will sort the 2 lines, then it will, okay, so it will concatenate to the stats.txt file that I created, which is empty now. So if I do this and Control O, Enter, Control X, So now I can see grade first. I don't have anything else in this name, so I can see the code is this. So if I want to run it, I will type bash, and I have to give a file name. So I can give, I have this ampersand at the rate dollar at the rate wildcard, so I can enter actually multiple files. So my regular expression will be something like this. This means that some files that contains any at first, and then a wildcard for these numbers, and a b, it can be a or b. You can see there are some z file as well, but I'm not taking those. I'm just taking the a b containing a or b, then .txt. So all the files which have these things will be taken by this script. So if I check the if I check the stats.txt file now, I can see the outputs are here. Previously it was empty, so you can see how shell script is working. Now I will go to another directory. So I'm back to data shell again. Here I have, okay, I have to go back and again. So here I have the sh.txt file. Basically it's a text file. If I it would be huge. Yeah, it's a text file containing a lots of text. So I will operate some grep command to find some regular expression. So -e is for expressions, regular expressions, and -n is for next line, I think. No, -n is for so if I give t, okay, first I need to give these wildcards, so it will search for all the d in the text file. So the text file is sh.txt, I think. Yeah, you can see all the, so n stands for the number of lines where these things are containing. But here you can see mathematical is also traced, so I don't want this, right? So what I can do, okay, firstly I will say there are a similar regular expression that will give the same output, that is this one with first bracket with a pipe inside. So basically it is saying that it can be t or t. So okay, it's not working. You can see it's the same output. You can see here is a d gradient, d1, mathematical, theoretical, all of them were addressed. So what I want to do is take just the okay, so here we eliminated some of the theoretical or something like those words. Then again we can do so if we use a caret here, then we do this, then we can see that this should be the starting of some sentence. So these are the results for those. And if we want to see something like so you can see that there are some, this actually says that th ... which means after th any character, then again any character. So it can be than, them, that, so many things. If we want to see any number, we can use 0 to 9 expression to find numbers, and this will give us all the text that contains that. Sorry, sh.txt. Okay, these are the So thanks, that's it for my shell lesson for NLP. There are so many regular expressions we can try on with this grep command. Also there is another command called tier, and it has some other expression search. So I'm gonna go for a simple one, that is 0 to 9. So it will actually trace all the numbers, and then I will give a /n, and it will take from sh.txt. So it will give trace back all the numbers that contains. It can be one digit, it can be multiple digit, as many as it wants. So this is how we can do some regular expression search from the texts. So thanks everyone. You can ask me any question if you want.